This is White Belt Class 3, the video for rich client applications and data types. I'll start off very briefly talking about rich client applications. So a rich client application is an application that runs on someone's machine and has a rich graphical user interface. There's lots of examples out there around. So on your computer, you may have a number of these. Microsoft Word is an example of a rich application. So I've got this nice design surface. I've got all these different buttons I can click. I can highlight things and do all sorts of things inside this, and it runs on my machine. So that's a rich client application. Excel is a rich client application. Again, I can do all sorts of things graphically using a mouse. I can still type using the keyboard. I've got all sorts of different things that I can do here. So lots of different things we can do here. Visual Studio is a rich client application because it runs on my machine. It's got places to click. Visual Studio Code is a rich client application. So these are all rich client applications. Again, they are graphical user interfaces, which means we allow the mouse to interact with it, and it runs on my machine, on my computer. Let's switch gears. I want to talk about data types. There is a video specifically around data types. Definitely take a look into that one and do some research on data types. I want to talk very briefly about what data types are and why they're important to programming in general. So data types, what's important to understand is data types are the structure of objects. It's the shape or the structure of information in a computer program. That's effectively what we've got going on here. So let me open up a little bit of code and we'll talk a little bit about data types. In all four of the languages that I'm teaching, all four of those are typed languages. They are strongly typed languages. The difference is JavaScript and Python are known as dynamically typed languages where the variable doesn't have a defined data type shape, but all four of them rely on strong data typing. So data typing, the way that works is there's a whole bunch of data types that are already provided to you, and you can create your own as well, usually by creating a new class. So any class we create is a data type. There's also, in some languages, you can create structs, you can create enums, you can create interfaces. So there's different types that we can do, but classes are the most common. So all of these different things are types. Probably the most ubiquitous type is the string type. Strings represent a sequence of characters. And we denote strings in most languages with double quotes. Some languages you can use single quotes, but most languages you can use double quotes. So a string, for example, might be my name. Chad is a string that has 4 characters. So the double quotes aren't part of the string. The double quotes show us that it is a string. So the double quotes are part of the data typing. It tells us the type of this thing, but the value of it is what's inside the double quotes. So Chad is a string. My first name and last name with a space is a string. It's a string of 10 characters. The first 4 are letters. The 5th character is a space, and the last 5 are my last name. So that would be a string. I could have a string of the number 1, 2, 3. Even though these are numbers, it's still a string because of the double quotes. So it's just a string of numbers in this case. I could say Chad 78. And now we've got a string that includes some numbers in it. My string could include special characters. My string could include new line characters and tabs, all sorts of different things. So everything between these two would be considered part of the string's value. So that's a string. Strings are all over the place in programming. They're one of the most common data types because they're so useful. The problem is you can't add strings together. If I had 2 strings of 1, 2, 3, and 4, 5, 6, I cannot add those together. I will not get 579 if I add those together. It just doesn't happen. I would need a different data type so that I could store these as actual numbers. And that's where the integer type comes in. So integer types in programming are whole numbers. Now we can take 1, 2, 3, and 4, 5, 6, and we can add those together. There's also floating point numbers or decimal numbers. So I could say 123.45 and 456.78. That could be a double or a single or a decimal. There's lots of different data types representing floating point numbers or decimal numbers there. These are just a few of the numbers. There are a few of the data types. There's date times, there's dates. Some languages have time only. Stop autocorrecting me. There are GUIDs, globally unique identifiers. There are UIDs, universally unique identifiers. They're basically the same thing, very, very similar anyways. Lots of different data types, tons of data types. We can also create our own data types. I could create a data type specifically for a customer object that maybe has a first name, a last name, a billing address, et cetera, et cetera. I could create, and these would also have their own data type. First name might be a string. Last name might be a string. Billing address might be its own address data type, which consists of street address, which is a string, city, which is a string, state, which is a string, zip code, which maybe is a zip code data type that has its own. So we can nest data types in themselves. So zip code might have characters. that would be a string, or right. So lots of different things that we can do with these data types. We can create our own custom data types. So data types just represent the shape of information, the shape of data. And every object that we create has a data type. It has a class. So let's talk a little bit more about what that means. So data types, if I've got some variable name equals Chad, this is going to have a data type that's a string. No, don't do that. So imagine for a moment that there is some class called string that somebody has created. Because that's effectively what's happened. If we have a variable string, there is some class string somewhere. Now imagine for a moment also that somebody created a method on it called substring. And substring simply returns some portion of the string. Maybe I want the first two characters, the last two characters, the first character, something along those lines. I could say var part equals name.substring, and now I can call that. But I can only call that because somebody defined this data type, and they defined a method on this data type called substring. So the data type is very important. The substring is only available because this is a string argument, and I know that because of the double quotes. Now imagine that we also create a type called an integer. Somebody creates a class integer, and again, we're going to create some method called add that takes some other number, and we simply return this plus other. So we're going to take ourselves, we're going to add other, that's going to give us a value. So we'll say var first equals 3, and we'll say var second equals first.add 5. So we'd imagine second would be 8. Again, this works because this is an integer. Somebody has defined this integer class for me. In all of the programming languages, somebody has already done this for you. And they've created some method called add that I can call. Now, most of the languages are going to overload the plus operator, but let's imagine for a moment it's just a method. So now we say add 5, and now we get another integer back because that's the return type of add. What I cannot do is say second dot substring. This doesn't work because second is of type integer. An integer does not have substring defined. Substring is defined on string. In all four of these languages, this will error out. In Java and C# we'll get a compilation error. In JavaScript and Python, we will get a runtime error. Substring does not exist on integer, and therefore this will error out. So the data type of the object is incredibly important. Even though these are all var, there is an actual data type underneath. In this case, it's an integer. So var is an integer. An integer, I can only call something that's defined in the integer data type or class. So add is totally fine calling on an integer. Substring is not. In this particular case up here, Chad is a string. Therefore, because it's a string, I have access to the substring method, and therefore I can call substring on it. So that's the foundations of data types. In C# and Java, variables are also strongly typed. I will go through that in another class. But for today, just understand that the data type of the object itself is incredibly important, and that will let us know what behaviors that we actually have available to us. I can't add strings together. I can't add dates together. It doesn't make sense. I can't add times together. It doesn't make sense. What does 3 o'clock plus 5 o'clock even mean? It doesn't mean anything. It doesn't mean 8 o'clock because you can't add 2 instances of a time. That just makes no sense at all. So it's important to understand that we define these data types because they mean something in the real world. And semantically, these method names reflect something that we would naturally do with those data types in the real world. So that's the foundation of data types. There's a whole bunch of data types. Definitely take a look at the video. Good luck on your class today.